Hello and welcome to another edition of Sparky Help. This time the easy guide to calculate series, resistance, inductive and capacitive or RLC circuits. And this time this video is in two parts. And in this particular video we're going to be looking at impedance, inductance, capacitance, AC theory. So as always, let's take a look at a question, and here we have a series circuit with the resistor, an inductor and a capacitor of the given values. We're going to answer this simple question. Determine the following from the drawing below. We're going to work out what VR is, what VL is, and VC when connected to a 230 volt 50 Hz AC supply. So in order to work out any voltage, the first thing it'd be nice to work with is to work out the current, and that's just Ohm's law. In this case though, it's V divided by Z. So we can put in the figures that we know. So let's put that in. Let's say 230 volts divided by Z, but we don't know what Z is. Z is a combination impedance of everything, so we've got to work that out. So let's put down the formula for Z. Z is equal to the square root R squared plus XL minus XC squared. Why is XL and XC subtracting? That's because they are opposites. Go look at my earlier videos on XL and XC. But they are opposite values. They are 180 degrees, and it's a bit like a tug of war between them, which one can win over the other. This one happens to say XL minus XC, but to be honest, it doesn't matter which way round that goes. It can be XC minus XL, and if that ends up being a negative number, it doesn't matter because when you square it, it will go positive anyway. So if we just remember it like that, put the figures in. If one is bigger or smaller than the other, just put it in the calculator. So let's put in the figures that we do know from that. And the only one we know so far is 45, because that's the resistive. We don't know XL and XC, so we're going to have to calculate those. So let's start off with XL. XL is 2 times pi times F times L. Let's put in the figures that we know from that, and there we've got our 2 times pi times 50, which is the frequency, and it's 180 millihenries, so 180 times 10 to the minus 3. Or you can divide all your answer by 1000, either or, as long as you get to an answer that should come out at 56.54 ohms. Let's do XC. XC is very similar in a formula, but this time the capacitive reactance is 1 divided by 2 pi FC in this case. So we can put the figures in that we have. It's 1 divided by the 2 times pi times the frequency, which is 50, times 95 times 10 to the minus 6, because it is microfarads. So as long as we put that into our calculator, that comes out at 33.51 ohms. So the inductive reactance is 56.54, capacitive reactance is 33.51. Remember, both of these are opposition to current flow. These can now go into the formula above. And we happen to have the big one. Take away the small one, but remember, it makes no odds. If we do that calculation, what you end up with is a Z, a total opposition of current flow to 50.55 ohms. This now can go into our Ohm's law formula at the top. 230 divided by 50.55 equals 4.54 amps. So we can now get back to the question in hand, which is calculate the three voltages. To work out VR, it's I times R. Because it's a series circuit, current remains constant. So we put that figure in. 4.54 times 45 gives us a value of 204.3. The others are similar. It's Ohm's law. So it's I times XL. Remember, it's Ohm's law. It's not called resistive law. So it's as long as an ohmic value goes in after the current and multiplies by it, then it will work out. So we put the figures in this time. 4.54, remember it's a series circuit, times 56.54 gives us a value of 256.7. And then last of all, VC, it's Ohm's law again. So despite moving on in your knowledge, we still come back to basic Ohm's law, which is taught very early on in your career. I times XC. 4.54 times 33.51 gives us a value of 152.1. So we now answered the question of what is the voltage across all of those components, and we have them there available to us. But these all equal 230 volts. How do they equal 230 volts? How can they add up to that? Because we've got the similar formulas before. We have those three voltages, but VL and VC oppose each other, so they're 180 degrees out of phase with each other. So if we put them into this formula, oh look, that looks very similar to the Z formula, and we get this as an answer, and that's where your 230 volts comes out. So if we do this calculation for those three voltages, this is why Kirchoff's voltage law, why his name sticks with it, because Kirchoff realised that if you add 204, 256, 152, it will equal 230 volts. So that's that first question. And obviously these are the values that we originally worked out. Let's have a look at this particular one then. So similar question, we've just changed the values. Determine the voltages again. So we'll start as we did before. So we want to work out the current. So Ohm's law, 230 divided by Z. We're going to find Z. It's that formula there, the impedance formula, which is 23 is the bit we know. We don't know XL or XC, so we've got to work those out. So there's our XL, 2 pi FL. Put that into our formula, and this time 2 times pi times 50 times 125 milli. That's 10 to the minus 3, or you could put in as 0.125, or divide all of your answer by 1,000, whichever you wish, and either way it's going to come to 39.26. XC is 1 over 2 pi FC. Put in that formula, 1 over 2 times pi times the frequency, which is 50, and 195 microfarads to the minus 6. And that comes to 16.32. These can now enter the formula above. And there's our 39.26 minus 16.32, and then square the answer to that. Just remember to use the brackets. And then that comes to a total of an impedance of 32.48. So we could replace all of that. That's equivalent to an ohmic value of 32.4. Into our Ohm's law formula to work out the current flow in our series circuit, and that comes out as 7.08 of an amp. And if we apply these to these voltages, then Ohm's law, I times R, and that gives us across the resistor 162.8, and across the inductor, same again, 7.08 times the 39, and that comes to 277.9, and then VC 7.08 times 16.32, and that comes to 115.5. So there we've answered our three voltages, but remember those three voltages will add up to 230. So those are our three voltages again. And again, we can use this formula, which is the same as the Z one, and putting those voltages in, that's where it comes up to 230. So there's Kirchoff's voltage law in action. So I hope that's been very beneficial and quite straightforward when you see it laid out like this. then it's a case of repetition and practice makes perfect. This is Sparky Help. Thank you very much.